All right, this is your stat sensei, Mr. Spensey, and we're going to be looking at, if I can find it, scenario 3 from the take-home quiz. It's a 2006 question 4. This is a very straightforward question, but we just needed to go back over this type. Patients with heart attack symptoms arrive at an emergency room either by ambulance or self-transportation provided by themselves, family, or friends. When a patient arrives at the emergency room, the time of arrival is recorded. The time when the patient's diagnostic treatment begins is also recorded. An administrator of a large hospital wanted to determine whether the mean wait times, time between arrival and diagnostic treatment for patients with heart attack symptoms differs according to the mode of transportation. Random sample of 150 patients with heart attack symptoms. We have a random sample of 150 who had reported to the emergency room was selected. For each patient, the mode of transportation and wait time were recorded. Summary statistics for each mode of transportation are shown in the table. So we end up having a total group of 150. These were randomly selected. We had a sample size of 77 that were taken by ambulance, and their mean wait time, or X bar, is 6.04, with the standard deviation of that sample being 4.3. We have 73 who took themselves, they drove themselves, or family or friends took them, and with a sample mean of 8.3 and 5.16. Use a 99% confidence interval to estimate the difference between the mean wait times for ambulance transported patients and self-transported patients at this emergency room. All right, so we have two samples. We're working with a t distribution because we have sample standard deviation. So that makes it a t. So two sample t for means, and we'll make sure we always name the tests. I don't think I said that in other videos. Null, the mean ambulance is equal to the mean sample, and I can use mu1 and mu2. Alternative, the mu of the ambulance time is not equal to the mean of the self-taking time. Please remember the reason. First off, I don't have to give the null an alternative because they're asking for a confidence interval. But all confidence intervals are set up as two sample test. A two-tailed test. So this is basically we need 99% here, and we need 0.005 there and 0.005 there, because our alpha area is essentially 0.01. All right. So while this is not required, sometimes it helps me figure out what's going on, but that's not required. Let mu1 equal the true population mean wait times for arriving by ambulance. Let mu2 equal the true population mean wait times for arriving by self, family, or friends. We need to state our conditions. First condition, random sample for both means of transportation was taken. This was given, so we didn't have to redo anything. The two samples are independent. It's unlikely that the number of patients that chose to use ambulance is likely to impact those driving themselves and vice versa. So we have to have two independent samples. N is less than 10%. Well, 770, reasonable to assume that there are more than 770 heart attack victims that take to the hospital by ambulance. And it's also reasonable to assume that there are more than 730 that choose to take that are driven by family and friends. Obviously, this would be over time and multiple hospitals. N is greater than 30 for both samples. All right, so this is our normality condition. Because N is greater than 30, in fact, N equals 77, which is greater than 30. And I probably should have written this. N is 73, greater than 30. The distribution of means is approximately normal by central limit theorem for both. Make sure you always address both. So here's my formula. Sample mean 1 minus sample mean 2 plus or minus T star S1 squared. All right, S2 squared over N1 and N2. Once we write that down, We cross it out. We don't want that to get us. So let's look back. We're going to go to the calculator and we're going to run this thing, fat test, and I guess we should go ahead and plug the values in. Well, we're going to go ahead and run it for a moment because that's going to be important. I may need to pause for just a moment. No, I don't. I'm good. All right. So I was making sure that I had all my information in input correctly. So X bar 1 is 6.04 minus 8.3, standard deviation 4.3, sample size is 77, and standard deviation of 5.16, sample size is 73. Make sure that you have your squares and all of this is correct. The one thing we haven't done is T-star. T-star we're going to have to come back and get because we're going to need our degrees of freedom. All right, and I'm just going to remind you, here's why. We're going to go second vars, inverse T, parenthesis 1 minus 0.99, close parenthesis, divided by 2, and ask for degrees of freedom when we don't have them. So here's what we do. We're going to go stat test, and we're going to drop down, and we're going to go 2 sample T interval. All right, so we have a 2 sample T interval. We have a mean of 6.04 and a standard deviation of 4.3 with a sample size of 77. We have a X bar of 8.3, a standard deviation of 5.16, and a sample size of 73. And we need a confidence level of 0.99. All right, we never pool. And we end up getting that value. And I'm going to go ahead and record that because I'm going to need that in a moment. The other information I need are my degrees of freedom. Well, it gave them to me. So my degrees of freedom are 140.37. Armed with that information, I can now calculate my T-star. So second vars, inverse T, area, parenthesis 1 minus 0.99, close parenthesis, divided by 2. Degrees of freedom, 140.37. And we end up getting 2.611. There it is. Okay. So we are 99% confident the true population difference in mean wait times for treatment. We have to say what order we did. Ambulance lies within the interval negative 4.29 and negative 0.23. Now, by the way, difference in mean. All right. All right. Difference in mean. It's important that when we're working with 2 samples, we're doing difference in means. All right. Based on this confidence interval, do you think the difference in the mean wait times is statistically significant? Justify your answer. Yeah, I do. 0 is not included with an interval, which indicates the difference in mean wait times based on mode of transportation is significant at what level? Alpha equal 0.01. We need to say, make the decision, say why. Well, we know it's significant because 0 is not contained. And at what level? Okay, why? Or what can we say? We conclude the wait times for those who were taken by friends or family was greater than those that were taken by ambulance because the interval is negative, indicating those taken by ambulance had less wait times than those taken by family and friends. All right. It takes longer to get seen in the emergency room if you're taken by family or friends. All right. Thank you for watching. I hope that helped. Hope to see you on the next one. And this is your Stat Sensei.